So the first statement about using measurement tools says for analog tools, report all known digits and one last estimated digit. And these, when you do this, those are what are considered the significant figures, or the significant digits. So first we need to talk about what is an analog tool. Does anybody know what we mean by an analog tool? Okay, let me give you the other choice between an analog tool and a digital tool. So a digital tool would be like a digital balance. When you put an object on it, do you have to read the scale that that digital tool is reporting to you? No, it tells you what the reading is and the unit. So then what is an analog tool? Can you think of an example of what might be an analog tool? A clock. Yes, a clock would be an analog tool. Yes. What would be the digital alternative to an analog clock? A digital clock, a stopwatch, right? Very good. What about something that measures length that's an analog tool? A ruler. What about something that measures volume that's an analog tool? Graduated cylinder, beaker, those are all analog tools. So what do we mean by analog compared to digital? What are you going to have to do with an analog tool? On a ruler, what do you have to look at on the ruler when you report a measured value? If you want to use that tool to measure. You have to look at the numbers and the increments and decide what they mean. So with an analog tool, you have to look and decide what the increments mean. And that's what we mean by analog. And then you have to read the measured value. Whereas with a digital tool, it reports the measured value to you. So when we're reading analog tools, we report all the values we can read on the increments and then one last estimated digit. And it is an estimated digit that you are going to decide on. So it will be between two increments, so you're going to have to estimate it. Okay? And when we report all of those digits, we have reported the significant figures. So let's look at this graduated cylinder. So when we're reading a cylinder filled with a liquid, what's going to form is a meniscus. What is a meniscus? That curved shape that a liquid makes when it's in a cylinder. So when we see that curved shape, where are we going to read? The bottom. So make sure you have in your notes, when you're reading a graduated cylinder, read from the bottom of the meniscus. So let's look at this graduated cylinder. I'm going to zoom in a little bit more. If we look at this graduated cylinder, do you guys see the curve on it? So that curve is the meniscus. We're going to read from the bottom of that meniscus. And you want to make sure you're eye level with the meniscus. So you're not above it or below it. You want to be eye level. So we need to look at our analog tool, in this case our graduated cylinder, and decide what each of the increments represents. So if we look, the big lines go by tens, right? So then if we start at 20 and go to 30, what do each of the smallest increments represent? One what? Milliliter. So the smallest increment is 1 milliliter. Right? So if each increment's 1 milliliter, then I can read this analog tool down to the milliliter, right? Those are digits I'll be able to see. So what's the first digit I know of? 3 in 30, right? And then I can look and see it's past the 31, right? And it's right about at the 32. So I can read the 3, right? And can I read the 2? And then what do I need to include? An estimated digit. So that estimated digit I said was 0.0. Would you have to say it's 0.0? No, it is an estimated digit. So what would be in reason for this question would be 31.9. Is that within reason? 31.8? Yep. What about 32.1? 32.2? Sure, all of those would be within reason. You are estimating the last digit. What would not be an acceptable answer is 32 milliliters. Why? You did not include for this measuring tool the estimated digit. So when another person looks at your measured value of 32, what do they think the estimated digit is? The 2. Are you estimating the 2? No, you can read the 2. So whenever we're reporting measured values on an analog tool, we need to report all the values we can read and one last estimated digit. And also, this brings us back to significant figures. If we look at the number 32, how many significant figures does that have? 2. What about 32.0? 3 significant figures. And we want to report all the significant figures we can, otherwise we're limiting ourselves and reporting a less accurate value than we were actually able to measure. Have you guys been taught all known digits and one estimated digit before? No. So that is what is accepted in science. So it's not a rule I'm making up, I promise. It is what is accepted. So let's look at some examples, some more examples for you guys to practice. So I'm going to zoom out a little bit. So if you guys will open this in your OneNote, I would encourage you to open it in your OneNote so you can see it. If you guys will try these 5 volumes, and then we'll go over them together. So what is the smallest increment on the graduated cylinder in A? 2 milliliters?
Oh, that's not what I was going to say. Never mind.
What's the smallest increment? What do each of the lines represent? 1 milliliter. So we should be able to read down to the 1 milliliter. So what did you guys report as the volume? What can we read?
37.
Okay, so we can read the 3, right? And the 7. And then what do we need? What? Estimated digit. What do you guys put for the estimated digit? 0.0. Did everyone put 37.0? Did anybody put 36.9? That is the same thing. What about 37.1? Same thing. What matters is you read the 3, and you read the second digit, which could be 6 or 7, and then you have the estimated digit in the tenths place. And then what do we need at the end of the number? The unit. What about in B? What's the smallest increment? 1? So then what did you guys read for the volume for this one? Same thing? Did everyone put 37.0? No, what did you put? Huh? 36.9, same thing. 37.1, same thing. 36.8, 37.2, all would be acceptable. What about in C? What's the smallest increment? 10. 10 milliliters is the smallest increment. So what can we read in this measured value? Okay. We can read the 4, right? And then what about the 0 and 40? Can we read the ones place? No. We're still going to include the 0. Why? It's our estimated value. And so what do we need to put at the end of our number to communicate that? Decimal point. And then we need a unit in the end. Okay? So in this number, the ones place is your estimated digit. So did everyone have 40? Did anyone have 41? Is 41 acceptable? Yes. Your estimated digit is in the ones place. 39 would be acceptable. On D, what's your smallest increment? 5 milliliters. Okay? So, what can we read here? We can read 55, 60, 65. And that's really all we can do. So when the increments aren't by 1 or 0.1, the best you can do is estimating in that smallest increment, is it 5, is it 6, right? Because this could be 66 or 67, right? Or 63. So do you see how the estimated digit in this case is in the ones place? Good. And the last one, what's the increment? Smallest increment? 0.1, finally. So 0.1 milliliters. So what can we read? 2.3. Those are our known digits. And then what do we need? An estimated digit. What did you guys put for the estimated digit? 0. Did everyone put 0? If I read this, I would probably say, I would have read it as 2.29 milliliters. It's the same thing. Do you see how our difference there is only in the estimated digit, really? Okay, good.